about a little while now, but good news is after science you will have another break. Yeah, go ahead, Jalissa. Thank you. You guys like my lab coat? I'm really getting into, the Bill Nye vibe right now. And I was in math in the morning, so I've already kind of like, see how everything's been going. You guys have been doing awesome as far as setting up your personal workspaces and continuing the same expectations. And I know that we're almost getting towards the later end of the day, and I just want to just remember that essentially when we are going through this, most of you guys will be muted. I am unmuting you for certain activities, but make sure that essentially when we're going through, it's going to be the same as in class. When you're taking notes, there will be little differences. As far as like questions, if you guys raise your hand like this, it's not as easy for me to see. It's actually better if you use the hand emoji. There's a lot of like movement happening naturally. I see that better than I will see you guys raising your hand. So that is just something I want you guys to keep in mind for when you want to answer questions or you want to model or when you want to read something. Now, before we go forward, please utilize the chat to privately chat. If you do have a question, we are really limited on time. In 7th grade, we ran out of time very quickly. This 40 minutes goes by really fast. So I will be cutting off questions at some point, and just quickly privately chat me if it says something really quickly that I can answer while we're going through the PowerPoint. All right, so everyone should be really familiar with using the PowerPoint for my class. It is going to be the same thing. I will post this PowerPoint. I'll send it to you guys. It's not for the full unit. It's on. I'm working through it. I want to eventually finish the whole unit and then just give it to you guys so you guys have the entire PowerPoint in case you miss notes. So right now, I'm going to put up the EQ and the recall. So quickly set up your notebook. Thank you, Kaylin. Awesome job, Kiara. And start writing the title for today's notes, which is the history of life. And this is 3 out of 16. That number may or may not change. Thank you guys for keeping writing while I'm speaking. I am working on finding a way for us to still complete kind of like labs. You guys know that lecturing is my least favorite form of teaching. And one of the things that I enjoyed so much about our learning space was the opportunities we were able to have to collaborate and work together. So I am working on a way to, instead of cutting those activities, finding another way to supplement them so you are still doing some sort of interactive lab and we aren't just kind of like taking notes and just speaking here and there. Let me get somebody to read our essential question for today. Prince, go ahead, read our essential question for today.
What does the fossil record of ancient life provide evidence for?
Beautiful. It's an amazing echo too. Can I have, oh, and I think it's Mr. Speziali, you are the person. When I'm doing this, because I am going to have scholars speaking a lot, if I forget to unmute or I'm not able to unmute someone, can you take over that responsibility so that I don't have to like scroll through people to find them because they do disappear off the panel. Thanks. All right, I have someone to read our recall for today's lesson. Oh, did I not meet someone? Deb, can you read our recall for today?
Evolution is the gradual change of a species over time.
Yeah, so before we went on break, we did talk a lot about evolution and what evolution was. So our recall is going to be revisiting the idea that all evolution is the gradual change of a species over time. It's not necessarily a disbelief in God or it's something that is not able to be seen. We are seeing species evolve. It's a change over a period of time. So when we're going to get started today, we're first going to look at some examples of fossils. So what type of fossil is called a body fossil? And it's easy to see some of these, especially with different types of marine life. The one that you are probably the most familiar with is a cast fossil, or a model fossil. So going back to this idea of a cast fossil, these are the ones like you ever seen Jurassic Park. You have like the insect that is encased in amber. That's what that is on the left. And you would find some insect encased on, it looks like a rock. Now, mold fossils, anytime you guys have been to a museum, you probably saw what's called a mold fossil. And that just means they took a mold of some sort of imprint in the fossil. Now, what you guys are seeing a picture of is Sue. And Sue is probably the most famous dinosaur in the entire world. And that's a picture of me and Sue together. It was a great experience. I was extremely happy, obviously. And you will find Sue at the Chicago Field Museum. At the end, if I have time, I will show you a trailer for a movie that you can find online, and it is really interesting because it's the story behind Sue. So why Sue is so special is because you are actually looking at one of the largest and best preserved dinosaurs. So she's a Tyrannosaurus rex, and she was actually not found that long ago. So I know a lot of people think of like fossils and they think, oh wow, they're just old things that people found a long time ago. But Sue was actually found in 1990. So she wasn't found that long ago. And she's named after the paleontologist Sue Hendrickson that found her. But the interesting and very cool thing about Sue is she is 90% real. So most of the, if you've ever been to a museum, especially in New York, a lot of the dinosaur fossils you'll see that look like this are actually just mold. So it's not the real fossil. But if you ever go to a Chicago Field Museum and get the chance to see Sue, it is the actual dinosaur. So all the fossils you are looking at are real. And she has a very interesting story because of essentially they fought over her as far as where they found her. And when she did go up for auction to be bought, she was bought for, I believe, close to $9 million. So she's worth a lot of money because of how important of a discovery she was, especially for evolution. All right, I'm going to skip that for now, and we're going to go straight into the text for fossils in ancient life. So can I get someone to volunteer to read for fossils and ancient life? Oh, Jalissa, of course. All right, Jalissa, go ahead.
Paleontologists are scientists who study fossils. They collect fossils and form these fossils. Sorry,
go ahead.
They interfere what past life forms were like, the structure of the organisms, what they ate, what ate them, and the environment in which they lived in. Paleontologists also clarify fossil organisms. They group similar organisms together and arrange them in the order in which they lived in, from oldest to most recent. Together, all this information about past life is called the fossil record. The fossil record provides evidence about the history of life on Earth. It also shows how different groups of organisms, including species, have changed over time.
All right, so something interesting, thank you, Jalissa, that we just read is this idea behind, it's not just what the creature looked like or the organism looked like. You can actually find out way more about them than just kind of what their body looked like or their structure. So one of the things that's interesting about Sue, I'll go back to her, the Tyrannosaurus rex from the beginning, is they actually found out what she died of. And she actually died of a parasite, so like an infection from a parasite that actually is still around today that kills birds. So that's what she died of. And we will talk about why something that was killing dinosaurs is still around today when we talk about the evolution of organisms. All right, so just like in class, the first part of our notes today is going back to what a fossil is. So a fossil is just the remains or impression of a prehistoric organism, and it could be preserved, petrified, or it could be found in a mold or a cast. That's the first part of your guys' notes today. Thank you guys for getting started right away. Thank you, Genesis, Jason, awesome, Eric. Good to see you. All right. And then who are paleontologists? These are scientists who study fossils, and there's still a lot of paleontologists around going out and on these field missions and studying and looking for different fossils. This is a reoccurring field of science. And a lot of people still participate in it today. Also, I saw a lot of hands raised. Don't forget to privately message me. The best time to ask questions, just like in class, is when we're kind of taking notes. I know some of you guys are quicker than others, and feel free if you do have a question to ask like during these kind of moments where we're taking notes. Guado, how's it going, buddy? You look frozen.
It's internet. I'm talking to him right now to try to troubleshoot it, Miss Pyers.
Okay, thank you. Jules, do you have your hand up? Yeah, what's up?
That's like petrified.
Yes, petrified.
Doesn't petrified mean scared?
Yeah, so it's called petrified because essentially like you're scared to, if you're frozen, right? That's what that means. So that's where you get that word petrified. It kind of has a double meaning. Good question. All right, I'm going to move on. And the last part is what the fossil record is. So anytime you talk to someone about, or you hear the word fossil record, all it is it's providing evidence about the history of life on Earth. And this evidence, this fossil record, which we're going to talk about today, shows how species change over time, which is evolution. So this is kind of answering our essential question off the bat. All right, I'm going to give you a little bit more time so you guys are still writing. Thank you guys for being on task. You're doing awesome. Quado, are you with us? Prince, you're good? Saw a thumbs up. All right, thumbs up. As I said, I was trying to unmute you, Quado, but it wasn't working. Oh.
Yes.
Are you good?
Miss Pyers? Yeah, I'm fine. How are you?
All right, fixed your technical issue. Awesome. All right, let's move on. I'll take a reader. Daniel, do you want to do readings? Are your hands up? All right, Daniel, read fossil.
Oh,
What's up?
everything is zoomed in, so I cannot actually see it.
That should be something on your end because it's fine here. Adjust one of your settings, maybe. All right, I'm going to meet you. All right, Olivia, you want to read? All right, go ahead.
Fossils in ancient life. The fossil record reveals a remarkable fact. Fossils occur in a particular order. Certain fossils appear only in older rocks, and other fossils appear only in more recent rocks. In other words, the fossil record shows that life on Earth has changed over time. In fact, more than 99% of all species that had ever lived on Earth had become extinct, which means that the species died out. Meanwhile, over billions of years, ancient unicellular organisms have given rise to the modern bacteria, protists, fungi, plants, and animals that we see on Earth today.
Good job. Thank you, Lydia. All right. So anytime they're referencing, showing how animals gradually or organisms gradually change over time, who can tell me what they're referencing to? This goes back to our recall. Anytime they're saying a gradual change over time, what are they referring to? What process or theory? Prince? Oh, hold on. Let me unmute you. Oh, the unmute button. All right, go ahead, Prince. What are they referring to?
They're referring to evolution.
They are. Awesome job, Prince. +1. They are referring to evolution. That is exactly that's exactly what I'm talking about. Kaylin, you have a question? No? Okay. All right. So our next part of our notes is going to kind of just expand a little bit more about what the fossil record tells us. So just like this really awesome graphic on the side, it shows, and we'll talk a little bit more about what these words mean and these eras, but essentially more than 99 of the species that have ever existed are now extinct. So most things that were living on this planet aren't living anymore. And we were able to figure this out looking at the fossil record and dating all of these species back. And the general idea is that the top layer is always going to be the most recent organisms, okay? And the ones all the way at the bottom of our fossil record are going to be the oldest or most ancient organisms are going to be found down there. And I could spend a whole lesson talking about the horseshoe crab and how amazing the horseshoe crab is. But if you look down all the way, it's on the last layer and to the left, that is actually a trilobite, which is the modern day horseshoe crab. They're very interesting. I've talked to horseshoe crabs for a long time. I'm not going to. But anyways, they've been around since prehistoric times, and they're around now. You see them a lot in Florida and the Carolinas. They're very, very cool.
Ooh.
Who did I? Oh, Lydia. Thank you guys for using the private chat. Yeah, Naima, let me unmute you for a second while people are finishing up these notes. Where are you? Yeah, Naima, what's your question?
How do you know, like when archaeologists dig these fossils down, you know you're not at the like core of the earth?
Are you asking how they know just by looking at them how old they are?
No, like how do they get down there to dig them up?
Oh, it's a lot. It's not necessarily that they're at the core of the earth. They're not that far down, but they are essentially, some of them are going like really deep into like caverns almost. We're going to talk about how they're able to know how old these organisms are based on where, essentially how they date them. And we're going to have a throwback to 7th grade science in a second when we talk about radioactive dating. That's a good question that I am. Let me find you, Kaylin. Oh, there you are. What's your question, Kaylin?
So you know how Naima was saying like that they go near the core, like they eventually keep going?
We don't get that deep into the earth. It's not like they are tunneling.
Oh, because I was gonna say, because they just fall out the earth or like burn.
Yeah, no. I know on the graphic it might look as if like it's kind of sized that way, but they aren't going that deep into the earth. That's these layers are not that deep. A lot of fossils you could actually find like maybe like a half a foot into the ground. You could still find, they're not that old, but you could find fossils buried like that. They're not going to be extremely deep. That's a good question. All right. Those other people who are raising their hands, just for the sake of time, privately chat me and I will address the questions as we move forward. All right. So next part. I'll take 2 readers for how exactly these fossils form. Kevin, and then my second reader will be Kiara. All right, take it away, Kevin.
A fossil can be as large and complete as an entire perfectly preserved animal, or as small and incomplete as a tiny fragment of a jawbone or leaf. There are fossil eggs, fossil footprints, and even fossilized animal droppings. For a fossil to form, either the remains of the organism or some trace of its presence must be preserved. The formation of any fossil depends on a precise combination of conditions. Because of this, the fossil record provides incomplete information about the history of life. For every organism that leaves a fossil, many more die without leaving a trace.
All right. Thank you, Kevin. Go ahead, Kiara.
Is formed when exposure to rain, heat, wind, and cold breaks exist rock into small particles of sand, silt, and clay. These particles are carried by streams and rivers into lakes or seas, where they eventually settle to the bottom. As layers of sediment build up over time, dead organisms may also sink to the bottom and become buried. If conditions are right, the remains may be kept intact and free from decay. The web of the layers of sediment gradually compresses the lower layer and, among with chemical activity, turn them into rock. I'm done.
All right. So Kiara, just to address your question, is a cast fossil a creature in amber like rock is trapped? Yeah. So if you ever like remember the movie Jurassic Park, he has like the mosquito encased in the amber. Yeah, that's when they're talking about like a cast fossil. And the notes, Lewis, I think there's about 2 more slides, but the slides aren't completely full. Is it let me unmute you really quick. Is it because you're running out of space?
What?
You said you asked me to unmute you about the notes.
Oh yeah, because I had a question.
Yeah, go ahead.
Oh, you know where the picture said that it said 2.5 billion years?
Mm-hmm.
Has anyone gone that deep to get a fossil from there?
It's so that's a good question. That's a really good question. Hold off because it's not necessarily that they're extremely deep. It is how we know something could be that old. So I don't want that's a good distinction to make. I don't want you guys to think that if the deeper it is, technically it's going to be extremely old. They don't very, 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 very old ancient fossils do not have to be buried underneath the ground that much to still be old. So I don't want you to look at this graphic and think that everything on the bottom is going to be essentially the core of the earth, because that's not necessarily true. Some of these ancient fossils could be maybe just like a couple of meters beneath the earth. This is all going to be found still in the sedentary rock. So they're actually not going that far into the earth to find these. All of you guys that have questions, just privately message them so that I don't waste time kind of scrolling through and trying to unmute you, and I can address them as we go. All right, let's move on to the next notes. All right, so this is a good example like of a graphic. So see how you have an ancient crocodile who dies in a river. What's going to happen is, remember the fossils are just kind of the preserved bones, and all it is the sediment's going to cover the body, and then millions and millions of years go by and the sediments essentially become rock, and that's going to fossilize it. The rock erodes, exposing the fossil. So you have this erosion happening, and that's how you can find some fossils just literally laying on the ground. In the trailer where they find Sue, literally it's almost like they find her fossils on the top of the ground. So I don't want you guys to think that like in reality we're sitting on top of all of these fossils. It's the idea of how they date them, which we're going to see next. It's not necessarily I found the crocodile 2 meters down, so he's this old, because eventually we know this about, you guys learned this in when you studied like the rock and the formation of layers of the earth, the layers erode. All right, let's move forward so we actually talk about how these things would be dated. So if I'm a paleontologist and I've collected several different fossils, what is my next step going to be? Who can tell me, if you're a paleontologist and I've collected all these different fossils, what am I going to want to do next with them? Luis, go ahead.
Try to see if they connect to each other.
Yeah, that's a good one. Try to see if they connect to each other. What's another thing I might try to do once I have them all? Maybe look at, see if they're connected. What else am I going to want to do? Because I don't know how old they are yet. Daniel?
Well, basically, you can see how much of the fossil you have, of the entire fossil you have, to see how much you can sell it for. And you might want to find out how much it's worth.
Yeah, I can try to, I want to find out how much it's worth. Claudio?
What? I was raising my hand.
Oh, okay. Thanks, Claudio. All right, so for the sake of time, I'm going to keep going forward. So just like Daniel said, you want to see how old it is to find out how much it's worth. Because the older and more rare these fossils are, the more it's going to be worth. So when we talk about dating fossils, this is what we're looking at. So what I want to do right now, okay, for the sake of time, I want you guys to, I'm not going to take any readers or volunteers. I want you to briefly read over these and look. We're going to write down the definition for relative dating and radioactive dating, because those are the two types of ways they figure out how old a fossil is. So really briefly read over this, and your next notes are going to be relative dating and radioactive dating. I'm going to give you guys about 3 minutes to read this over, and then I'll take some volunteers to tell me what the definitions for those two terms are. Go ahead. I'll give you guys another minute. All right, by show of a hand, who can tell me what relative dating is? So that method of interpreting a fossil, what is, when I say relative dating, what am I talking about? Oh, am I gonna cold call? Oh, Lewis, thank you, Lewis. What is relative dating?
Seeing the layers of the rocks in order.
Yeah, so this is that when we talked about looking at comparing it to the placement of other fossils in that rock. So if you have different layers, you can actually just compare them, and then this is just in a rock, and you can see, kind of compare it to the other ones. And we had an activity with this lesson that was going to have you guys kind of do that, but we can kind of do it ourselves, just looking at that image that we looked at before. And the other type of dating is radioactive dating. Who can tell me, this is a throwback to 7th grade, what is radioactive dating? What are we looking at in order to age these fossils? Hyra, can you tell me what radioactive dating is?
Radioactive dating is when the scientists, they figure out the age based on how many radioactive isotopes it has left in it.
Yes, that's exactly what it is. So remember in 7th grade, in the beginning of the year, when you guys were going over atoms and they're looking at carbon. So carbon-16 is what they use to date fossils. So that's actually the radioactive isotope that they look for And that's how they're able to see how old a fossil is based on how much of that radioactive isotope is in the fossil. So radioactive dating is probably the best way in order to find out more accurately how old something is. So the next part of my notes is, I believe, the last part. And as you guys are writing this, I'm going to go through the chat and answer some questions. And these are, I believe, this is one of the last slides. So it's our definition for relative dating. And this is just determining age by comparing it to the fossils in other layers of the rock. Can people become fossils? Yes. We typically, they're called, most of the time we found fossils, it's almost like they look like the primates. This recently happened, I forget what they named him, but they recently found a fossil of one of the kind of first forms of like a man. And that's and then mummies are not necessarily fossils, it's a different type of like ancient human. We wouldn't necessarily call them a fossil, but we have found you know, older preserved forms of humans for sure. Let me see. How long does it take for something to become a fossil? It really just depends. It typically, it's nature is causing the fossil to occur, so that's why it's kind of varies. That's a good question. I don't know specifically how long, and it also depends on the organism as well. Yeah, you guys can head to the bathroom whenever. I trust you guys to do that. Oh, packets. Okay, that's a really good question, Naima. I want to address that formally today. I think I have 8 minutes left. Yeah. Naima, I will get to that at the end. No, so Daniel, the rock moves up to the surface because the layers above it are eroding. Okay, man, Kevin, okay. That could be a whole lesson on how we know how many years it takes for carbon-16 to decay. So we can tell based on how much is left in the fossil, how long that fossil's been around based on how long it takes for that element to decay. So really channel your brain back to the beginning of 7th grade, because that's when you guys learned about that. So it's really kind of, it's a hard process to explain in like 2 seconds. Yeah, I can find it. I'll make a note of that, Lewis, and I'll find a pic and add it to the PowerPoint for tomorrow. Oh, how thin was the Earth at the beginning of time? I don't know, Eric. It's wasn't that different in shape. Alligators, most reptiles are. Yeah. Horseshoe crab is the most ancient, one of the most ancient organisms in the world. All right, so let's move forward. And okay, I'm gonna skip through this, and I'm gonna go straight to okay, what the homework's gonna look like. So we don't have a lot of time. So you guys know that for the most part in class, we did not really use the packet. And that was on purpose because I was creating the system to go straight to PowerPoints. Even the connections part in the beginning of class, we had a PowerPoint. That is going to be the same system. And I do want to be able to get to a point, because the 7th graders already asked me this. They were like, oh, how do I get to, can we still do the Vanna White? Can we still go up to the board? I am working on that, because essentially it will be to where the packet is fully just on the PowerPoint. And for homework, this is the way your homework is going to look like. It's going to be maybe 1 or 2 short response questions. And that is really it. Now, the way that I'm going to have you guys send this to me for homework is through Zoom chat. You do not need to write out the question. I know what the question is. All you're going to do is write 1 and 2, depending on the format of the homework. Sometimes it might be 1A, B, C, whatnot. And you're just going to answer it and then send it to me in the chat. I'm not having you guys hold a piece of paper up to the camera or anything like that. These 2 questions essentially are the the bulk of, if you were to take away anything from today, it would be, this is what's most important. So you are not getting packets. I cannot be in charge of making sure those packets get to you. So I don't even want to rely on someone else to do that, and then hope that they get to you, and then hope that it's the way it should be. So we're just going to do the straight PowerPoints, and everything's going to be done in your notebook, like notes like we did in class. I never had you guys hold on the packets anyways. For our choice. Prince, what does that mean? Are we doing one for our choice? Oh, how do you send it via chat? Kaylin, just like you just sent me that message. Literally, you just privately send me the message, write 1, and then your answer, and then 2, and then your answer. Prince, you're just answering question 1, so explain why. And then number 2, you're just giving one conclusion. Why scientists, what that many scientists have made about the past based on it. Yeah, like Naomi, that's a perfect answer. And that's really it for the homework. And the structure, that's why I'm kind of glad with the PowerPoints that we were already doing this before all this madness happened. Yeah, Kaylin, you can answer them right now. So Kaylin said, I only know how to text you while I'm in a meeting. You can send the homework to me right now. One of the things that I am noticing is that I think once the meeting ends, the chat goes away. Hopefully, right now we're talking about getting Google Classroom, something that I would have loved to have in the beginning of the year. And this will all be so much easier because the PowerPoint will be on there. You can message me on there, all of those things. I'm going to be showing you guys Remind app tomorrow, and I'm going to have you guys get Remind app, and that way you can message me and I can send out whole group announcements at any moment. So stay tuned in that for tomorrow. Does anyone have any questions to privately chat me right now while you have me on here? We have about 3 minutes until you guys go to break. Everyone's good. Awesome. Angela, it's so wonderful to see you. Christina, awesome. Can I email? Yeah, go ahead, Kevin. You can email me. That's fine. Prince. I love science too, Prince. Oh, Jason, I was just asking if you had any more questions. Oh, my here, guys. They can tell the difference because they look at what the bones look like and what the organism looks like. That's how they kind of like classify the different. I didn't think to talk more about the fossils of the human man. I'm gonna make a point to talk more about that tomorrow because I forgot that was probably questions you guys were gonna have. So I will gather more information because I don't think this unit. I think after today we don't really talk about fossils that much. But the recent discovery is pretty interesting. So you have a question? Just send me a question mark. Where are you, Jalissa? Oh, there you are. Jalissa, what was your question?
Oh, are people buried considered fossils, like dead people in graves?
Yeah. So going back to like our notes for what fossils are, when we go back to, I think our first, yeah, they're just a prehistoric organism that's preserved. There is a prehistoric, they call it prehistoric man, and they named, I want to say his name something weird like Buddy, but it's just essentially prehistoric man. They have found fossils of prehistoric man that have occurred. They would not consider like a mummy prehistoric because of when those people, like King Tut's mummy, they have his coffin in a museum, but they would not consider him prehistoric because of it wasn't that time period that the Egyptian King Tut was around. It wasn't that, technically in the grand scheme of things, wasn't that long ago. Video. Did I? Yes, Lydia, I got it. All right, you guys are awesome. We are officially on your second break. I hope you guys have fun in the specials, and I will see you at the end of the day.
Ladies and gentlemen, one announcement: we do have a new link for the specials thing. We had to change 7th grade classrooms because there was a little bit of a hiccup in terms of technology. So I'm going to send that out over chat to everyone. What you're going to do is just join this meeting during specials. I know we have writing first, but at 3 o'clock, you will join this meeting that I'm sending out right now, okay? Hold on just a sec.
This is our break.
Yep, just dial into this. The numbers are 973 945 049.
What?
All right. So, but we'll have writing first, and I'll see that I'll see y'all there.
Oh, Erda, what specials do they have?
I believe it's music today.
Oh yeah, that's exciting. I gotta tune into that.
Wait, Erda, did you send that out? I didn't get it on my end.
Yeah. Oh. Yeah, it is sent into everyone. Give it a second.
Okay, that's fine. Erda, this is also a good opportunity to see if you blow up the whole thing if you leave.
I know I do though. So why do we keep doing this? We're just doing this, and I'm feeling worse and worse about the fact that I'm the glitch in the system here.
Well, try something new. So do you have leave meaning or end meaning in the bottom right? Did he go?
Yeah.
I knew it. He was trying to tell me we had to redo the whole thing.
Do you, well, because there's a difference. You can say leave meeting or end meeting.
Yeah, he was like ending meetings before. We're still good.
Daniel.
You guys can go enjoy your break, by the way. Oh, I have to stop recording.